Good morning, everyone. Whoa, my name is Paul Hallett, and I'm a developer evangelist at Twilio. For those of you who don't know, Twilio is an API that lets you send and receive SMS messages and place and receive phone calls through your web and mobile applications. And as of last Thursday, we now do MMS as well. So we're an API, and I've spent around about the last 3 or 4 years of my life learning how to build good APIs. Python is my language of choice, and I'm here today to tell you how you can build great APIs using some existing technologies that are available for Python. But obviously, we should start at the beginning and ask ourselves, what is an API? Because an API, to a lot of people, has different definitions. You've probably all heard of requests. Hands up who hasn't. Go learn what it is. Requests is probably the most downloaded open source piece of software available for Python from PyPI, and part of its success is due to its good API. It has good functions and methods. It's well documented. These are its set of interfaces to its piece of software. So an API is a set of interfaces that allow you to interact with a piece of software or service as well. I'm sure you've all used pieces of software in the past that have been really hard to figure out how to use. This is an example of bad API practices. We're not talking about software APIs today, though. We're talking about web APIs. And web APIs are an interesting topic because a lot of people tend to assume they know what is a good web API, what REST is, what REST isn't. And we're going to cover that right now. So I just want to make it very clear that REST does not just mean Hypertext Transfer Protocol. REST is a series of guidelines. Do pick me up if I say standards there, because REST is a series of guidelines, and it's not a set of standards. A set of guidelines on how to build a good API. The major concept of REST is that it turns everything into resources. So your users. On the Twilio platform, we have SMS messages and voice calls. These are all resources that you interact with through the API, and these should be your main point of interaction. You shouldn't be calling functions through a REST HTTP call. You should be calling resources and using methods on those. So just a few more examples for resources on other APIs. Who's used Stripe before? Or PayPal? They often have credit card transactions as their resource. SendGrid do email. They have messages and emails as their resources. So a good REST API will be based around resources. And we interact with these through HTTP. And now HTTP is a standard. And there's a concept in computer science that we all know called don't repeat yourself. Don't reinvent the wheel unless the wheel's broken. In this case, we don't really need to reinvent the wheel. HTTP provides us with a set of standard ways of interacting with these resources. And that's through HTTP methods or verbs and HTTP status codes. Now your methods are your CRUD actions: create, read, update, and delete. A good REST API will use HTTP get, post, patch or put, there's controversy there, we'll talk about that later, and delete to perform actions on these resources. So if you want to delete a resource, you would use a HTTP delete. Who's used the Twitter API before? Twitter API, I'm sorry for here anyone who works for Twitter, your REST API is bad. Do you say /tweet/destroy? That isn't REST, that is your own kind of idea of REST. I wish I could work for Twitter and get rid of the whole wording of REST through their documentation, because it isn't. Again, another story, talk to me about it later, I could rant for hours on that. So a good REST API will use HTTP methods to interact with those resources. If we want to create a new one, we just use a post or a put if we know the URI that we want it to be on. And the status codes, these are going to be sent back to us in our responses. So I'm sure you've all seen a HTTP 404 file not found page before. This we can use in our API to denote that this resource doesn't exist, or we can't find what you're looking for, what you're asking for. We can use a HTTP 200 when we've created a resource, when we've found a resource and we've delivered it back to you, and we can use, for example, a HTTP 201 created response when we've created a resource. But REST isn't just about, resources and HTTP. It's also about being stateless. So stateless is a twofold thing. It means that you never store any session information on your server, your API server, about what people are doing. You don't include cookies. The reason for this is twofold. You don't want your service, which could be doing upwards of 1 million requests a day, to be handling a load of session information, because it will fall over. Your API is there to deliver information to the user when they request it. And everything that they need to make that request and response cycle successful should be included in that request, such as their authentication tokens, the information they're querying on, and then their response, the representation of the resource that you're giving back. There's also a security issue here. If someone manages to break into your session, they can do whatever they want with their service, a potentially financial issue or potentially more serious issue with people's privacy data. So if you are using an API, a REST API, make sure you're not storing session information. REST, as applied to web browsers, does not work here, obviously, because we don't want to have to log in every time we go to facebook.com. If anyone here uses Facebook, I've left it. It's bloody annoying. We also don't want to have to tell the web browser which web page we're on, or where we are, say, in YouTube or whatever website. That's stored on the service. So REST doesn't apply so well to web applications, but for APIs, it does apply very well. And finally, another concept. Has anyone heard of HATOS? HATOS, does anyone pronounce it differently? I hear some people say HATOAS, which is potentially rude. HATOS stands for Hypermedia as the Engine of Application State, which is a really fancy way of saying provide hypermedia links in your representation of resources. This line that I've highlighted here is a hypermedia link to a resource that I've requested from an API that I built last October, which is based around Pokemon. We'll show a demonstration of that later on. Providing these hypermedia links allows software to discover links that are resources that are linked to this resource, so that have relationships, so that you don't have to trawl through documentation to discover it yourself. Ideally, in the most perfect world, a REST API wrapper should never have to remember any links like hard-coded, because it can just search through the response, find these hypermedia links, and it can say there's this resource link there. So those are the four major concepts of a good REST API. Resources, it uses HTTP methods and status codes. It's stateless, and it uses HATOS. If you don't use HATOS, you can have a good argument with Roy Fielding if you ever meet him. You're probably all asking me now, why do I care about this? We're all Python developers here. I don't care about REST. If I wanted to talk about REST, I would go to, I saw someone nodding then. I would go to an API meetup. Well, APIs provide a lot of extra potential to existing platforms. If you're building platforms now, or if you're building them in the future, an API can dramatically extend the capabilities of that platform. Facebook and Twitter are really good examples of this. Twitter is arguably successful because of its API, which in the early days allowed third-party developers to create a bunch of novel applications or new clients that Twitter eventually ended up buying. And Uber, which is a service for using taxis in a lot of the major cities in the world, have recently launched an API. So you can now use Uber through Google Maps and other applications such as Expensify without you actually having to use the Uber application. So what they've tended to have done is they've built their application without thinking about APIs, and they've turned their users or their applications or their cars or their products, and they've turned them into resources in their API. This doesn't always work quite well. If you're going to be building an application and you're not going REST API first, make sure you can account for it in the future, because you're going to need to be able to represent that RESTfully correctly with good documentation, so do keep that in mind. That's how it's been going for the last 15 years or so with a lot of these web applications. They're building a platform, they're realizing they can extend it later on with an API, and they do so. But in the past 5 years or so, we've seen platforms come out that are purely APIs. They wrap a very simple interface around an extremely complex service. SendGrid allows you to skip IMAP and POP3 and just do REST APIs for emails, and they use webhooks to deliver emails to you. Stripe are now competing with PayPal for REST APIs for credit card transactions. And again, Twilio allows you to do SMS and voice through an API, and solving the telephony problem of having to set up your own asterisk servers and negotiate with hundreds of carriers all over the world. So where does Python come into this? Well, I've just explained to you a bunch of guidelines about REST. Python is renowned in the programming community for having a lot of its own guidelines and standards on how you should write Python. You should always make sure you have PEP8. You should always make sure you do WSGI correct. Because REST is also the type of technological concept, which isn't a set of standards and it's a set of guidelines, Python developers can easily translate that kind of nag in their head to do PEP8 to make sure they always do REST in their API. And I'm going to run through some of the best, in my opinion, the best interfaces for building RESTful APIs now in Python. And the first one of those is Flask RESTful. Has anyone ever used Flask RESTful before? So this is actually what the Twilio API is. The Twilio API is a Python API layer on top of a giant Java box, but we're not here to talk about bad technology. So we're going to talk about Flask RESTful instead. This was open source by us. It's available for you to download, and it obviously, as its name implies, it sticks on top of Flask. It's good for microservices. You just define a class and you set methods which are linked to the HTTP methods, such as get, post, put, and delete. And then you would interact with your database here and return some sort of dictionary. Flask RESTful will transform this into XML and JSON for you, which is very nice. And finally, you add your resources down at the bottom line before the if name equals main, setting up the URL routing. So you can do this in one file, just like Flask is really good for an application in one file. The second one that I'm going to, if you want to find out more information, bit.ly/Flask RESTful. The second one that I'm going to talk about is TastyPie. If anyone knows me, TastyPie is, you'll know that this is my favorite way of integrating an API into an existing Django web application. I'm going to have to shout now because I'm not actually going to give you examples and slides. I'm going to live code an API for you now to show how quickly you can build an API into an existing Django application. Okay? Can you all hear me okay? Lovely, right. Has anyone used TastyPie before? Oh, cool, awesome. Right, okay, let's dive into some code. So I'm using a Django 1.7 application. Thank you, Andrew Godwin and everyone else at Django for launching that. I've just installed two things. I have TastyPie and a model that I'm going to use Pokemon as an example here. Again, if you know me, I'm pretty crazy about Pokemon as well as Python, so I always try and mix them together. I've created a model, a very simple model with two attributes, a name and a Pokedex ID. We won't go the full-blown with a Pokemon model here because it could be gigantic. There's a lot of information about Pokemon. You'll be surprised. The main focus of our work is going to be in this file, which I've called api.py. And this is where we're going to link our resource through our API to our model representation in Django. So I'm just going to quickly go ahead and from tastypie.resources import model resource, and then I'm obviously going to import my Pokemon object. We're going to build a class. The convention tends to be model name resource, so Pokemon resource, there we go, and we're going to subclass this from the model resource. This will do the brunt of the work for us. We could do anything complex and interesting inside this class now if we wanted to, but TastyPie is going to be looking for a meta class. And within that meta class, it's going to try and find two attributes. The first one of those is called the query set. What do you want to expose through this resource? In this case, we want to expose all the Pokemon objects. If you were building an application that provided, say, articles in a blog post, you could filter this on your published articles or on, say, deleted messages, for example. It also wants to know which methods we're going to use, HTTP methods, as I described earlier, and we're going to allow get and post. We're not actually going to use post today, we're just going to use get, but that should be everything you need to write in this API file. The second thing you need to do in your URLs is set up the routing, because we need to find a way to be able to access this resource through our URL routing. So obviously we are an API, we're building an API here, so if you say from tastypie.api, import API, and then we're going to quickly import that resource that we just created. I should have picked a shorter word. Right, so let's go ahead and instantiate our API, and then we're just going to register the Pokemon API on it there. And we do need to instantiate that there. Now I have added this URL here, mostly because I'm terrible at writing these live. I always get them wrong, so I've done them beforehand. That should be everything we now need to do. Yes? Tastypie, thank you so much. That would have been dramatically terrible if it had gone wrong. Right, let's dive. So this should now be running. Did anyone else point out any mistakes? Just in case? Okay, let's go ahead and fire a HTTP request to this and see if it's worked. We're going to find out if it went wrong. There we go, we need to do that on the end. So the API has now been generated and it's providing us with a list of resource endpoints. You see here we have a Pokemon endpoint. We have its schema, which we can look at. /Pokemon/schema. And it will tell us all the attributes in that resource. And we can obviously go ahead and grab the very first Pokemon, which should be Bulbasaur, with its ID and its resource URI. So Tastypie has built all of that for you. So anyone out there, whoever has a project manager who says to you, I want to integrate an API into this Django application, and you turn around and say, that will take me hours, I've just done it in 5 minutes for you. It's very easy to do if you need to do it. So let's dive back into the rest of the presentation. So if you want to learn more about Tastypie, bit.ly/Tastypie. I can't believe that these bit.ly links, by the way, have not been taken yet. That's pretty impressive. And finally, the one you probably all know I'm going to be talking about is the Django REST framework, which is probably the best Django REST framework available for Django. I just want to give a shout out to Tom Christie, who managed to raise a phenomenal amount of money recently on Kickstarter to bring this up to version 3.0. Can we give him a little round of applause? I know he's not here, but well done, Tom. So with Django REST framework, this is the one that you want to use if you want to do a lot of your own computation, if you want a very flexible and complex interactivity with your API. Django REST framework is the choice to use. I know Eventbrite use Django REST framework. I think Heroku might do as well. There are some big names out there who are using this, so it's a very popular one. The first thing we're going to need to build in the Django REST framework is a serializers.py file. This will go in your reusable app. This basically links an attendee to your model to a serializer. The model I'm using now is a Pycon attendees. This serializer will basically transform that model into its JSON or XML representation. In the views.py, as in our normal reusable app, we want to define our query set, very similar to how I did in Tastypie earlier. And we want to say which serializer class we're using from that previous slide just there. And then in our URLs, we just set up our router, which we're using a default router here, and we register the /attendee. The slash will be added for you, and you'll then be able to have a fully web browsable API through the Django REST framework. Can I just see, I know I had some people put their hands up for Tastypie. How many people have used Django REST framework before? That's a lot more. Okay, so that's very cool. So again, you can find out more about Django REST framework at bit.ly/REST framework. So that's REST APIs. They've been around for quite a while now, and a lot of people are asking me at API meetups. I run the London API meetup. If you're ever in London, do come along. What's going to be next? REST APIs have been around for ages. We're kind of getting to the point now where you can't really use REST APIs for the functionality that people want to provide through an API. What is next? And I personally think the next thing that's going to really be big for APIs is webhooks, which is actually an extremely ambiguous term for what it is. A webhook is actually more like a trigger. So the way this would work, a service. Let's use Twilio as an example. So when you send an SMS message or a voice call to Twilio, that will trigger a webhook, which is basically a HTTP request to your application with a bunch of information about what just happened. So the traditional way of APIs is a developer will send a request to a service. The service will do a lot of magic, and it will send you back a response. In webhooks, we flip things around. The service is going to be triggered, and it's going to send you a HTTP request with information. You're going to then do something magical or whatever you want to do with it, and you send back a response. Now, the response part is important because a lot of webhook services these days don't actually expect a response back. If you're going to be building webhook services, please make sure you include a response. I believe it's part of HTTP's standard to always send a response to a request, and a lot of webhook services don't do that yet. There are some webhook stuff being done in Django. Danny Greenfeld is working on a DJ webhooks application. I believe it's not completely finished yet, but I would recommend anyone who wants to help to push this forward to check this out. So, as a recap, HTTP APIs are really, really popular right now. If you're not providing an HTTP API somewhere in your service, you're missing out on a lot of potential extra use. And you should be doing HTTP APIs right. Just like everyone in this room wants to do Python correctly, you're well positioned to adapt that nag to do Pepe and stuff correctly with REST APIs as well. So make sure you do, if you're going to do a REST API, do it the right way. If you feel like you need to reinvent the wheel, that's perfectly fine. Just make sure your documentation covers exactly what you're doing. And of course, I've just shown you 3 examples of ways you can build APIs with Python, but there are many more out there. I just had a conversation with one of my friends who's actually put a very thin layer onto his own application because that's the way it works best for his service. So that was a very brief talk on how you can build great APIs in Python. I work for Twilio and my name is Paul Hallett. If you have any questions, you can either tweet me or get hold of me at paul@twilio.com and I'll take a few questions from you now. Thank you very much. Ooh. Yes. Oh, okay. So that is it's HTTP Py. You can just pip install it, and it just allows you. It just gives you this kind of command line called HTTP, and then it will fire just request, and it does that nice, snazzy coloring and everything like that. So HTTP Py. It's a Python thing. So, anybody else? Yeah.
You said that TastyPy is your favorite, and then you mentioned, of course, Django REST as well. Could you go into a little bit about what's different between them and why one might choose one rather than the other?
Yeah, so the reason TastyPy is my favorite is because it's really quick and easy to just take what you have as your Django application and represent that through a REST API. There's very little configuration you have to do in order to set that up and say, I have these objects in my Django database and I just want to expose them for a REST API. TastyPy, in my opinion, is the best way to do it. I built an API last October and it took me all of 10 minutes to do the REST API part of it. Most of the work was done in my Django application. Django REST framework requires a bit more setup, and there's a lot more you have to do in terms of there's a lot more flexibility, which means there's a lot more onus on you as a developer to work on that. It's much better for a much larger API, but if you just want to quickly expose your certain objects in your database through resources, TastyPy would be the way to go.
Can you both experience how to best communicate failures back to the requester in your API? So somebody asks you to send an SMS and it fails and you want to give a passable result so you can deal programmatically.
Do you mean in the concept of webhooks, or do you mean as a standard REST API?
In a REST API.
Okay, so yeah, I guess I'll use Twilio as an example again. We have an extensive set of documentation on various errors that occur that are specific to Twilio, specific to telephony. And we provide those errors with links to the documentation pages for the developers when those errors occur. We also have, in our part of our service, we have what we call an app monitor that will basically email you or harass you when you have errors to let you know that things are going wrong beyond REST APIs. Obviously, you can use the standard 4XX HTTP codes when you need them, where they apply, but there are instances, obviously, where HTTP can only provide so much information. But you should still be using the right HTTP codes related to the issues. For instance, if an SMS is never delivered, you should use, I think we use a 404 not found, as in it hasn't been delivered, but then you get an extended, this is also the Twilio error, here's the documentation on why it's broken. At the back.
You promised tantalisingly earlier that we might talk about the internal put versus pack debate.
Yeah. Okay, so patch is very recent, and a lot of servers haven't supported it. And there's this argument over when you should use patch and when you should use put to partially update resources. With put or post, it's expected that you send the entire representation. With patch, you can just fire off little bits. I think the issue at the moment is the lack of support for patch. I think we should go towards patch. I don't want. I mean, if people have opinions on whether we should stick to post and put instead of patch, I think why not support the whole lot? Just support all three of them. There's no issues there. I know Eve, which is like a micro framework specifically for APIs, supports patch now, and I believe I'm not sure if Django REST framework does or TastyPie does. I'll have to look into that.
I guess it does, actually.
It does. Oh, there we go. It does. Yeah, I'm sure Tom is going to bring that out in 3 if it wasn't already there. So, yep.
What tools or library might you recommend for functional testing building?
For testing your APIs, that's a good question. I was thinking earlier today, someone's going to probably ask me about testing APIs. So I guess you could, if you wanted to, mock the views through TastyPie. It's not a very good way of doing it. There is the request factory in Django, which is specific to Django for testing those APIs. You could use a third-party service like RunScope, which will actually test your API endpoints. It's kind of like an automated. Has everyone heard of Postman before? It's like a Chrome plugin / web application that will test your endpoints for you. You obviously want it to be part of your test suite though. I personally would just use the request factory for TastyPie to test those endpoints. I'm not entirely sure what you use for Flask, as I'm more familiar with Django. Time for one more? Yeah? Time for one more? Awesome. If you want me, if you want to speak to me, come and find me. I'll put a red jacket on so you can find me. Okay? Thank you very much.